Okay, type 3 binary compounds. Remember, type 3 binary compounds are made of two nonmetals. Right? Type 1 and 2 are both metal and nonmetal, meaning type 1 and type 2 are both ionic compounds. Type 3 compounds are not ionic, which makes sense because if they were ionic, you'd be taking two nonmetals, both of which have a negative charge if they were ions. Two negative charges are not going to attract together. They're going to get as far away from one another as they can. Okay? So, type 3 compounds can't be ionic. All right? It's a different kind of compound. We'll get into that later. All right? So, naming type 3 compounds. Because they're not ionic, you can't look at charges and switch charges and things like that to figure out the formula. But what that means is it gets actually pretty easy because the name of the compound has to tell you the formula of the compound. Okay? So, the way to name a type 3 compound, you put the first element first, and you just name the whole element. Nothing changes. All right? You put the second element second. Man, this is hard so far, isn't it? Put the second element second, and it ends with IDE. Sounds pretty familiar to this point, right? Here's where it kind of veers off. All right? Because you don't have charges, you have to be told what the formula is in the name. And so what we have is we have a series of prefixes that tell you what the formula is. Okay? So, those prefixes. Mono is 1. Di, not bi, di is 2. Tri is 3. 4 is tetra. Then, after that, you kind of think geometry. Penta is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona, 9. Deca, 10. And we don't need to go beyond 10. All right? So, you're going to use some prefixes to tell how many of each type of atom there are. Okay? So, first element, second element, ide, prefixes. Okay? You got to know the prefixes. All right? Now, couple little hitches in it. The first, you never use the prefix mono on the first element. Okay? Anything else will always have a prefix. Okay? So, but if there's only one of the first element, you don't put mono on it. If there's one of the second element, you do put mono on it. If there's two of the first element, you do put di on it. Okay? The only time you won't write a prefix is if there's one of the first element. All right? The other thing is, with oxides, because you got kind of two vowels kind of crunched together at the end, usually with the prefix and the oxide, okay? If the name gets a little weird to say, you make it easier. You lop off the end of the prefix, okay? So instead of saying monooxide, which kind of sounds like you're stuttering, monooxide, you just lop off the end of that prefix and you call it monoxide, okay? Pentoxide, heptoxide, okay? You just lop off the end of that prefix, all right? So, let's try some, shall we? BF3. We have one boron, right? So it's boron. We have 3 fluorines. What prefix means 3? Tri, like a triangle, right? Okay, so 3 fluorines, and then it ends with IDE, just like every binary compound ends with IDE. Okay, BF3 then becomes boron trifluoride. NO, 1 nitrogen, so nitrogen, Now, 1 oxygen. Again, on the second element, there's always going to be a prefix. But because there's only one, then the prefix is mono, but monooxide is kind of weird to say, so we just call it nitrogen monoxide. Notice a couple things. First, you don't change the ending of the first name. Okay? Second name will always end with "ide." All right? And the second element will always have a prefix on it. First one, not necessarily. All right, N2O5, 2 nitrogens, dinitrogen, 5 oxygens, pentaoxide or pentoxide. Dinitrogen pentoxide is the name of that compound. Again, type 3s are pretty easy if you recognize that they are type 3s. Okay? You just say however many. With type 3s, there's no switching, there's none of that. It's just how many of this element, how many of this element, this prefix, this prefix. All right? Now, there's a couple of compounds that you got to watch out for because we don't use systematic names for them. One of them, H2O. You know what H2O is. You don't call H2O dihydrogen monoxide. You don't do it. Okay? You call H2O water. Right? Another arguably equally important compound is NH3. NH3, nobody calls nitrogen trihydride. Nobody does it. That would be silly. Okay, and if you ever say that your science teacher told you that you could call it nitrogen trihydride, I will hunt you down. All right, because I didn't say that. Right? Nitrogen trihydride is not nitrogen trihydride. It is ammonia. Okay, yeah, the stuff that's in Windex. Okay, this is an incredibly important compound. Not because everybody needs to have clean windows. Okay, but a more important use for ammonia is it's used in fertilizer. Ammonia is the primary reason that the earth can produce enough food to feed 7 and change billion people. Okay? If it weren't for ammonia, we couldn't produce enough food to feed everybody. The earth wouldn't support it. All right? So, needless to say, ammonia is a pretty important chemical, and it's involved in lots of chemical reactions and things like that, and so it's its own name. Okay? It's ammonia. All right. Now let's get really easy. So writing formulas of compounds, of type 3 compounds. All right? Basically, what the prefixes tell you to do, you do it. So carbon monoxide, 1 carbon, 1 oxygen. So the formula is CO. Nitrogen dioxide. No prefix on nitrogen, so there's only 1. Prefix of di on oxygen, which is 2, and so that is NO2. Selenium hexafluoride. No prefix on selenium, 1. Hexa on fluoride, SeF6. Dinitrogen monoxide. 2 nitrogens, 1 oxygen, N2O. Diiodine heptoxide. 2 iodines, 7 oxygens, I2O7. Doesn't get a lot easier than that, does it? Okay, so type 3s, students usually like these. Okay, but the trick is, you got to be able to know that it's a type 3 compound. Okay, so get really, really used to figuring out what type of compound you have, and then worry about the rules for naming and such. All right. So now we're done. You can name any binary compound ever. All right? Next, we're going to move on, and we're going to start talking about some compounds that are not binary compounds that have more than 2 elements in them.